So we are going to look at exponential and logarithmic functions. Now, if you have watched any kind of news lately and have seen data from, I should say, early on of COVID, you already know what an exponential function looks like. Sadly, things that rise very, very quickly, right? And so we're going to see that the big number on the bottom is called the base, and then notice the exponent in this case is a variable, and that makes this exponential. Something like x squared is not exponential because the base is x and the exponent is a number. So remember that you have your exponent is going to be a variable. And you will see that the shape of this function, certainly has a lot to do, as you saw back here, of the value of the base. The graph will always be above the x-axis, so it can never go negative y value. Y-intercept is 1, because if I'm at anything to the 0 power, that's going to be 1. It climbs very quickly. Exponentials are very fast. Has the x-axis as its horizontal asymptote. And of course, as it says here, the larger the base, the more steeply the graph rises. We can also have fractions, which you'll see a lot of times these are written as negative 1/10 written as 10 to the negative 1. Okay, so you'll see that the negative sometimes will be on the exponent. I kind of prefer that. You'll see me use that a lot. Mainly because students don't like fractions, but you may not like negative exponents either. Same rules follow here. It's going to always be positive, going to go through the y-axis. If I have a 0 power, it's going to equal 1. The smaller the base, the more steeply the graph falls to the right. Many applications. Many applications. Like I mentioned already, typically any type of a disease, I used to say, take your kid to daycare with the flu and see the next day how many have the flu. Anything like that certainly shows exponential growth. You see it a lot in populations. Also, and of course money. Let's hope, right? Your bank account. Also, you have to realize that when it was rising, that's going to be exponential growth. But also when it falls, we can talk about decay. And that's what this example here, I'm just going to show it because I'll go through, of course, many examples on the videos. But typically you see these a lot, these type of functions to do in finance, banking, and interest. All right? So we'll have lots of fun with those. After exponential functions come logarithmic functions, and the reason why these are actually inverses of each other. So in other words, a log function is an exponential function. Students really struggle with logs because they don't like the way this looks. But if you continue to tell yourself that a log, so base 10, remember we said the base is the big number, a log is just simply an exponent. And so we'll go through, again, I'll just kind of show these on the screen. We'll go through how to find logarithms, because we can rewrite them as exponents that you're used to using, or you will be at this point. And of course we can have different bases. The log is base 10, so that's why you see all the 10s here. But you see the base e. If you're not familiar with e, if you put it in your calculator, it's like e to the first power 2.718. It's like pi. It's just a special number that actually showed up a lot in banking, and so it got its special letter there. But ln then is base e. Okay, so you can have different bases as well, and they don't have to be just base 10. But if the number's not there, it's understood to be base 10, or you can have base e, but there are certain different bases for logarithms. This is what they look like. Again, the inverse of an exponential. One really important thing to note is x can never be negative. So a lot of times students will try to plug these in your calculator with a negative x and wonder why you get an error. That's the reason why right there. We will look at the different properties. So you can see some properties here. We'll look at different rules, these properties, to be able to solve these. If we want to change the base, we have a change of base formula that we can use. And once again, we're going to define this as an actual function. But it is very important to note, very important, that a logarithm and an exponential are inverses of each other. And that's why we have this look where the line y equals x just cuts them right in half. And so exponential functions, the domain, remember, is your x values. You can plug in any x you want. However, the y, you will never get a negative y. So that's why it says the set of all real numbers. Notice these flip, and that's actually a property of inverse functions, is that the domain becomes the range, and the range becomes the domain for the logs. And we'll talk more about asymptotes. Again, we really want to be able to solve these type of equations, so you will deal a lot with the different properties. We'll go over each one of these as they show up on assignments. And so as you get used to these properties, you will see that it's easy. Well, I don't want to say easy. I know you don't like when math, especially math teachers, right? It's easy for you, right? But as you get these properties down, it makes it easier to be able to solve these and then to be able to use them in applications. So there you have it. We're going to have fun with exponential and logarithmic functions so we can actually see how these are used in the real world.